eyes, look me in the face, tell me that you love me, even if it's fake, 'cause I don't.
Water is one of the most valuable resources on Earth and is essential to keeping us alive. But tap water isn't pure H2O, it also has salts and other chemicals. Water districts report the concentration of these other chemicals as the total dissolved solids or TDS. When the concentration of TDS is too high, the water may taste bad, make people sick, or damage plumbing. Let's take a look at our school's water supply and think about how we can tell what's in our water. Now that we know there are salts and other chemicals in our water, how would you go about finding the concentration of a specific chemical, like chloride, in our school's tap water?
Why don't we let the liquid water evaporate and weigh the chlorine left behind?
That's an interesting idea, Tina. What do you think?
Hello everyone, we're going to talk about gravimetric analysis. So what is gravimetric analysis? A gravimetric analysis is a technique which the amount of analyte and ion being analyzed can be determined through the measurement of mass. It also depends on comparing the masses of two compounds containing the analyte.
If we can't use evaporation, how can we separate out just the chemical we care about?
Maybe we can filter it out?
Let's think about Diego's suggestion a little more. Imagine a coffee filter. When you pour water over the coffee grounds, what happens?
The grounds stay in the filter, but the water goes through.
That's right. Aqueous particles will pass through the tiny holes in the filter, but solids cannot.
Only solids can be filtered out, right? So, how will we find the concentration of a specific chemical if it is dissolved in the water?
What if we make the dissolved solid into an insoluble solid?
Yes. That is what we call a precipitation reaction.
One common method of gravimetric analysis is precipitation gravimetry. A precipitation gravimetry is an analytical technique that uses precipitation reaction to separate ions from a solution. The chemical that is added is called precipitating or precipitating agent. The solid precipitates can be separated from the liquid components using filtration, and the mass of the solid can be used along with the balanced chemical equation to calculate the amount or concentration of ionic compounds in solution. So, let's take a look at a problem regarding gravimetric analysis. So, this is the question.
A 0.4450 grams solid mixture containing calcium sulfate is dissolved in water and treated with an excess of barium nitrate, resulting in the precipitation of 0.6168 grams of barium sulfate. The question is, what percentage of the mixture was calcium sulfate? So let's take a look at the equation that is associated with this. So we've got calcium sulfate, and remember, we're treating this with an excess barium nitrate, and that is regenerate a barium sulfate precipitation, and then calcium nitrate. That's just gotta be expected are ions. And also the solid mixture. We know that we got 0.6168 grams barium sulfate precipitate. Able to get the precipitate, remove it from solution, find the mass, and we got that mass, the precipitate. So we're gonna do stoichiometry. First of all, whenever we do stoichiometry, we know we don't want mass. We need moles because moles allow to do stoichiometry. A 0.6168 grams barium sulfate times 1 mole divided by 233.38 grams, which is the molecular mass of the barium sulfate, is equal to 0.002643 mole of the barium sulfate. Now we also need to understand is that the number of moles of barium sulfate precipitate that is also equal to the number of moles of calcium sulfate because the ratio of this is 1:1. and the 0.002643 mole of calcium sulfate times 136.14 grams of calcium sulfate, which is the molecular mass of this, and divided by 1 mole of calcium sulfate, and the result is 0.3598 grams of calcium sulfate. So this gravimetric analysis allow us to figure out what mass of calcium sulfate was in the solution. A 0.3598 grams of calcium sulfate is divided by 0.4450 grams of solid mixture times 100 and ended up to 79.08% of that solid mixture was calcium sulfate.